Back everyone. So I thought that today in this video I will discuss seasonality and how can we compute seasonality index. So let's look at the data that is given to us in this problem. Um, so this is all the data that is provided to us. Everything that's on the left of this box. So all of this data is given to us. So we know what is the quarter one demand for year one, year two, year three, year four. We also know what is the quarter two demand, quarter three demand, and quarter four demand for all the possible years. So these all data points are provided to us, and now our first task is to compute the seasonal factor for the different quarters. Okay, so remember that seasonal factors are calculated with respect to the time horizon. Here that instance is quarters. Okay, so this is the formula from the book. The seasonality factor SI for a time period I or for a quarter I is given by DI over summation of D. So again, DI is all the demand or some of the demand belonging to quarter I and then this summation D is the overall sum, or the cumulative sum, if you want to call that. So and that's the reason why I have already computed these sums for the different quarters and the different years. Okay, so again I took a luxury of summing this row. So 45 plus 70 plus 100 plus 100 is equal to 315. That's my column that computes the sum for each quarters. Similarly, 100 plus 170 plus 285 plus 215 equals 770. And you could either sum of these numbers, 315, 2015, 3100, 770, and you can end up with 6200. This is our cumulative sum. Okay, so similarly I also computed the sum for the years. So the total demand for year one is 1000, 1200 for year two, 1800 for year three, and 2200 for year four. Remember that the totals or the sum data is not given to us. We have to compute that in order to find out the seasonality factor. So again, let's find out the seasonality factor 1. So again, this is for quarter 1. What is SF1? So SF1 is given by D1 over summation of D. What is the total demand that belongs to quarter 1? It's 315. All right, so the intuition behind the seasonality factor is we should be able to capture the fact that the demand in Q1 is considerably lower compared to the demand in Q2, and we need to adjust our forecast accordingly. Okay, so this is equal to 315 over 6200, and we can use our calculator to find this out. So 315 over 6200, 315 divided by let's just reset this, 315 divided by 6200 equals 0.05. so that is 0.05. And similarly we can find out SF2, which is again D2, that is a demand in total demand in quarter 2 over summation of D. So D2 is 2015, and then this is 6200. So when you divide these two numbers, you get 0.33. Similarly, you can do this for quarter 3. Again, now it's d3 over summation of d, and that is equal to 3100 over 6200, so that is equal to 0.5. And then SF4, that's the seasonality forecast for quarter 4, that is equal to d4 over summation of d, and now it's 770 over 6200. So let's find that out. 770 divided by 6200 equals 0.12. So these are our seasonality factors for this quarter 1, this is quarter 2, quarter 3, and quarter 4. Okay, so how do we use the seasonality factor? That is a key question. And again, we can use the seasonality factor with any forecasting techniques. So remember, in this forecasting module, what we have been doing so far is we know what is the demand in year 1, we know what is the total demand in year 2, we know what is the total demand in year 4, we know what is the total demand in year 3 and year 4. Now our task in this module is to figure out what is the total demand in year 5. So this is the unknown that we are interested in finding out. And again, remember, we could use a wide variety of methods to figure out this unknown based on the historical demand data. We could use moving average methods, we could use exponential smoothing methods, we could use the linear trend line. Okay, so let's use the linear trend line. So I took the luxury of calculating the value for A and B for the linear trend line. So now again, it's a intensive calculation process, so you need to figure out the value of B first using this relationship, and then once you have the value of B, you can figure out the value of A. Okay, remember, to calculate A and B, what we are using is, okay, we are using X as the year number. So we have year 1, year 2, year 3, year 4, and then Y is your actual demand. So the Y values, now we know the Y values, it's 1000, 1200, 1800, and 2200. So we know these values, 1000, 1200, 1800, and 2200. So now it's just a matter of using calculating summation of xy, x bar, y bar, summation of x square, and we did this in a previous video. We need to figure out xy, we need to figure out x squared, and then after we also need to figure out x bar and y bar. And n, the value for n is the number of observations, it's 4. We have done this in a previous video, so I'm not going to repeat that process, but this is a good point where you can practice by yourself whether you arrive at this equation or not. So remember, I did this in advance. Y is 420x plus 500. That is what we'll use to forecast demand. This relationship between x and y. So now if I ask you what is the forecasted demand for year 5, okay, as soon as I say year 5, that should ring a bell that the value for x is 5. Now how do we find this? We know that we are going to use this relationship provided by the linear trend line. So now the value for y when x equals 5 is 420 times 5 plus 500. So that's your that is your forecast for the 5th year according to the linear trend line. So that's 2100 plus 500, which is 2600. Okay, So again, what we just did was use the linear trend line as the forecasting method, and we figured out that the forecasted demand for year 5 is 2600. Now is where we use our seasonality factor to distribute this demand across the various quarters. Okay, that's the advantage of using the seasonality factor. Now we are capable of using these numbers to distribute this demand, this total demand, across the different quarters. So we know that demand in Q1 is relatively lower compared to the demand in Q2 and Q3, and the seasonality factors capture that. So the way we figure out the adjusted forecast, or the seasonality adjusted quarterly forecast for year 5. So let me write that down here. So seasonality adjusted quarterly forecast for year 5. How do we figure that out? So we have to perform this operation, and that's called SF1, SF2, SF3, SF4. So we have to we have our forecast F, and we have to multiply that with our seasonality factor S1 here. The same operation, you multiply this with S2, you multiply this with S3, and you multiply this with S4 to get our seasonality adjusted quarterly forecast. So in a way, what we are trying to do is we are trying to distribute this 2600 across the various quarters, keeping in mind that demand in Q1 is very low compared to Q2 and Q3, and these factors are actually capturing that. So what is this saying? This is saying that only 5% of the total demand should go to quarter 1, 50% of the total demand should go to quarter 3, and so on. So this is what we can use. So let's figure these quarterly forecast value. So SF1, we just calculated the forecast. That was 2600 times S1 is 0.05. So that is SF1, and that is equal to 2600 times 0.05. That is 130 units. Okay. Similarly, you do this for the second quarter. SF2 is 2600 times the seasonality factor. Seasonality factor for quarter 2, which is 0.33. So, and again, I meant to say adjusted seasonality forecast, so that is ASF. Okay, I'm sorry that I wrote SF here, but I hope that's clear. Okay, so 2600 times 0.33, that is equal to 858 units, and then here it's 2600 times 0.5, which is 1300 units, and the last one is 2600 times 0.12. so that was our fourth seasonality factor, 0.12. So that is equal to, let me use my calculator, 2600 times 0.12, that is equal to 312 units. Okay, so essentially what we did was our total demand was 2600 units, and this is how we should distribute it across various quarters. And what we did in this problem is made use of seasonality factors, which were computed based on the historical demand data. So for instance, here we know that seasonality factor for quarter 1 should be very low compared to quarter 3, so which is evident from this numbers 0.05 for Q1 versus 0.5. So I hope this analysis was clear, and again I'm going to scan this and upload it to Canvas, and I'll see you guys in the next video. Thanks a lot.